Special right triangles. When we say the word special right triangles, what we mean are two right triangles where the angles are nice. Now, in every right triangle, one of the angles is 90 degrees. So the other two angles also add up to 90 degrees because sum of all the angles in a triangle is 180 degrees. In the first special right triangle, I have 45 and 45 degrees for the acute angles. And here in the second one, they're not same. One is big, the other is small. The smaller angle is 30 degrees and the larger angle is 60 degrees. So this is what we mean by special right triangles. And why do we call special? And you'll see in a minute. But before that, we want to address about all right triangles. Whenever you have a right triangle, then you're thinking this picture of a triangle where one of the angles is a right angle, and there is this side, the largest side, is opposite to the right angle. It's called the hypotenuse, and these two other sides are called the legs. So there are two legs and hypotenuse. Now, if the legs are denoted by A and B and hypotenuse by C, then we have Pythagorean theorem. So if the legs are A, B, and the hypotenuse is C, then we have this relationship A square plus B square equals C square. It's called the Pythagorean theorem. Now, for these two special right triangles, we can label the side lengths as well. So when I have the first special right triangle, then I have a 90 degrees angle and 45 degrees. If two angles are equal, that means I have an isosceles triangle, which means that these two sides are also equal. So the two legs are going to be equal. And if they are equal, let me say that this is 1, then this will also be 1. And I can use Pythagorean theorem to get the hypotenuse. So if I square 1, I get 1, and then plus 1 square, again 1. So 1 square plus 1 square is 2. So square of c is 2, which means c has to be square root 2. So this is what the proportions I have for the side lengths of the first special right triangle. The way I want to say it in words is, in the first special right triangle, the two legs are equal. The two legs are equal. And then the other note I want to make is the hypotenuse is root 2 times a leg, and you can multiply by either of these legs. They are same. So this is the first characteristic of a first special right triangle. The legs are equal and the hypotenuse is root 2 times as big. So if I want to work out some examples, then say I've been given, so if one of the acute angles is 45 degrees, then it forces the other angle also to be 45 degrees. So say if I'm given that this side length is 3, then this leg is 3, which means I can solve for the other measures of the right triangle. So this angle will be 45 degrees and the other leg will also be 3, and the hypotenuse will be 3 times root 2. The hypotenuse is root 2 times a leg. And let's go ahead and write down one more example where this time maybe I'm given not a leg but hypotenuse. So say this is 5 square root 2. Then How do I solve? Well, hypotenuse is root 2 times as big. So if I want to go to the smaller side, if I want to get the leg, then I have to divide this by root 2. In other words, this will be 5 and that will also be 5 and this angle will be 45 degrees. If you divide 5 root 2 by root 2, root 2's cancel each other out and you get 5. Or you can also say, what number should I multiply root 2 by to get 5 root 2? And then you know it has to be 5 because 5 times root 2 is 5 root 2. So that's the characteristic of first special right triangle. And the problems there involve only either multiplying by root 2 or dividing by root 2. So let's try to multiply some numbers with root 2. So let's carry out these multiplications. What is 7 times root 2? Well, there's no other way to write this. You just write it as 7 root 2. What about root 3 times root 2? Now, if you have two square roots, then you can think of multiplying 3 times 2 and you get root 6. Notice, I did not multiply 7 and 2 because one did not have the square root and the other did. So I just leave it as 7 root 2. But here, I will multiply the 3 and 2 because they are both under the square root. All right, what about 5 root 2 times root 2? So this time, 5 does not have square root, but I can multiply it root 2 and root 2. And that would just give me 2. So this actually becomes 5 times 2, which is 10. So that's how we multiply by root 2. If the other factor also has a square root, then you multiply 2 with whatever is under the square root. But if the other factor does not have square root, then your answer is just that integer times square root 2. All right, let's practice some division. So I'll say divide 6 root 2 by root 2. Then you're simply cancelling out the root 2's and you get 6. So that wasn't bad. Now, if I have something like 6 divided by root 2. All right, so this looks like 6 divided by root 2. And now, I don't have a square root 2 up on top to cancel like in the previous example. So what I could do, and what most students know to do, is to multiply and divide by square root 2. And that works. So 6 root 2. And when you multiply root 2 with root 2, you get 2. And now you can cancel out this 2 with the 6. The 2 does not cancel with the root 2 because one has square root and the other does not. But I can cancel the 2 with 6 because 2 goes into 6 3 times. And the answer is 3 root 2. Let's do one more. What about 5 square root 10 divided by square root 2? So this time, now I can divide these two numbers, square root 10 divided by square root 2, because they both have square roots. And so 2 goes into 10 5 times. Look, this 5 stays outside, and then root 10 divided by root 2 is root 5. All right, that's what we need in order to work with first special right triangle. Let's look at the second special right triangle. So there I have 60 30 degrees angle. So I no longer have equal legs. So this angle is 30 degrees, this is 60 degrees, and that's a right angle. Now, we have Pythagorean theorem, but these two sides are not equal, unlike the first special right triangle. So there, if this was 1, this was also 1. But I can take these to be 1 each because they are different. So, but the other thing is, this is 60 degrees, that's a 30 degrees. And if you reflect this triangle over this base, you notice that the original triangle is half of an equilateral triangle. So that's what you get. So this is going to be 90 degrees, that is 60 degrees, and that is 30 degrees. So your original blue triangle was actually half of this equilateral triangle. Which means if you take the side length of this equilateral triangle to be 2, so let me label this as 2, then this side length of the big triangle is 2, but I'm only focusing on my original blue triangle. This is actually half of the total, which means this is 1. So now if I were to isolate just the blue triangle, I get 60 degrees here, 30 degrees there, 1 and 2. Now I can use my Pythagorean theorem. If this is a, then a square is 1. B I don't know, but I know a square plus b square is 2 square, which is 4, which means 1 square plus b square is 2 square. So 1 plus b square is 4, which means b square is 3, or b is square root 3. So that's what I have. So these are the proportions for the second special right triangle. You don't have equal legs. You have a short leg and a long leg and hypotenuse. If the short leg is 1, the long leg is root 3, and the hypotenuse is 2. So let's redraw that picture and make those notes. "60 degrees, 30 degrees. Side opposite to 30 degrees is 1, short leg. Long leg is root 3, and hypotenuse is 2. So let's write this down. The long leg is root 3 times the short leg, and the hypotenuse is 2 times the short leg. So this time there are 2 factors, unlike the first special right triangle. In the first special right triangle, both legs were equal and hypotenuse was square root 2 times as big. So there was only 1 factor to remember, but now we have to remember 2 factors. And both are expressed in terms of the short leg. The long leg is root 3 times, and root 3 is about 1.73. So if you're thinking money, then if this is $1, this is $1.73, and this is $2. So the hypotenuse is exactly double. The long leg is root 3 times as big. So let's look at some examples. If I'm given the short leg, then it's easy to tell the other 2 sides. And you may only be given one angle. Then you know the other angle. If this is 30, that has to be 60 because they both add up to 90. Now, if I'm given the short leg, say the short leg here is 9, then can I solve the entire triangle? Of course. This angle will be 60 degrees. Notice, this is the long leg. Long leg is root 3 times the short, which means it's 9 root 3. And the hypotenuse is 2 times 9, so that's going to be 18. Hypotenuse is double. Now, what would we do if we are not given the short leg? Now, here is my recommendation. Always find the short leg first, even if it is not part of the problem. So if this is 30 degrees, say you're given the long leg as, say, 7 root 6. Then how are you going to solve? Well, this angle is easy. It's 60 degrees. So if the long leg is 7 root 6, how do you get the short leg? Well, from short leg to long leg, you multiply by root 3. Now you have to divide by root 3. So what is 7 root 6 divided by root 3? Well, you can divide the root 6 by root 3 and you get root 2. And the 7 stays in place. So that's our short leg. So this is going to be, so let me redraw the picture. So this was given to us, 7 root 6, 30 degrees. Then we didn't have to do any calculations here. This would be the complement of 30, which is 60. And we just figured the short leg has to be 7 root 2. Now, from the short leg, we can find the hypotenuse. Hypotenuse is double 7 root 2, which means you got to multiply 7 root 2 by 2. Now, how do you multiply? Well, this 7 does not have square root and this 2 does not have square root. So you think of multiplying this 7 with this 2, you get 14, and then the square root 2 remains in place. So this is 14 root 2. Or you could have said right here, the 7 should become 14 when you multiply by 2. But you don't think of multiplying the 2 with the root 2. You only have to multiply one factor. And let's do one more example and then I'll have practice problems and answers will be in the description. So say I have been given the hypotenuse. If I'm given the hypotenuse, so say if this is 60 degrees and the hypotenuse is 8, how am I going to solve? Well, first of all, the angle is easy part. It's a complement of 60, so that's going to be 30. Now, the hypotenuse is twice as big as the short leg, and this leg is short. How do I know that? It feels smaller, but the more accurate reason is it's opposite to the smallest angle, 30 degrees. So that's why this is the short leg, and that's the long leg. So hypotenuse is double the short leg, which means if hypotenuse is 8, to get the short leg, I have to divide by 2, and I get 4. So always find the short leg first, and then you can get the other side. So in this case, the long leg, it's 4 times square root 3. So that's what we have in special right triangles. I have some practice problems here, and it says find the unknown side. So you're not solving for the entire triangle, but you're only finding the side. So let me put it so you can see all the problems. So now it looks like we have a better focus now. All right, that's all I have for this video, and I'll see you in the next one. Thank you.